So you want to get back into chemistry after kind of missing chemistry for maybe the summer or for a year. You took chemistry honors maybe, and now you're trying to take AP chemistry or something like that. Well, this is a good reviewer video for you to get back into the rhythm of what you kind of learned, and hopefully this helps you bring back a lot of concepts. So let's say we have a chemical equation like this. So mixing nitrogen and oxygen here will give us N2O5. So the first thing we're going to do is we're going to talk about, we need to talk about stoichiometry. And we're going to use stoichiometry to do calculations. In fact, the question that I'm going to ask you is, let's say we had 10 grams of N2 is reacted with 10 grams of O2. So the question would be then, what is the theoretical yield of N2O5? To approach a question like this, we need to first understand that we're going to use dimensional analysis and a topic known as stoichiometry. Now, stoichiometry just allows us to convert between moles of one thing to the moles of another thing with ratios, and that's going to allow us to get from 10 grams of N2 or 10 grams of O2 to grams of N2O5. That's going to be really important. But the first thing you need to do is make sure you balance the equation. So while there's a storm outside, we're going to analyze this equation. So there's 2 nitrogens and 2 oxygens on the left. There's 2 nitrogens and 5 oxygens on the right. So the oxygens aren't balanced. Now 2 and 5 aren't, well, 2 is even and 5 is odd. So there's no way to multiply 2 to get 5 as a whole number. These are whole numbers. What we're going to do instead is put a 2 on the right here. We're going to force this right side to be an even number. And that'll give us 4 nitrogens on the right, because it's 2 times 2, and 5 times 2, which is 10 oxygens on the right. So we need 10 oxygens on the left as well. We need the same number of oxygens and nitrogens on the left as the right. Well, that's pretty easy to do now. We just put a 5 there. Are we done? No. 10 oxygens, 10 oxygens. However, we have 4 nitrogens now on the right side, so now we're going to put a 2 on the left here of next to nitrogen, and that'll give us 4 nitrogens on each side. This is a balanced equation because we cannot simplify this any further. What these numbers tells us is that, for example, 2 nitrogens are ratioed, we should say, with 5 oxygens. 2 nitrogens go with 2 N2O5s. And so same goes for O2. 5O2 is proportional to 2 N2O5. So these ratios are going to allow us to convert between moles of one compound to another when we do the stoichiometry. Okay, with the balanced reaction, what you're going to do now is figure out which of the reactants are the limiting reactant. So the reactants are on the left side. Okay, what you make is the product. Makes sense. So is N2 the reactant that's limiting, or O2 that's the one that's limiting? Now the limiting reactant is simply whichever element runs out first in producing N2O5 here. So let's say that you have, with 10 oxygens, you can make 15 of these. But with 10 nitrogens, you can only make 12 of them. So the nitrogen is going to run out first before the oxygens can, be used. It's kind of like leftover ingredients, right, after making a pizza. So we need to figure out what that is, and that will give us the theoretical yield. Because if nitrogen runs out first, there's no way that O2 can by itself is going to make any more product. So I'm not going to talk any further, and let's just get straight into it. So 10 grams of nitrogen. Let's start with nitrogen. We're going to figure out which of the reactants is limiting. First, we want to convert this to moles because the ratios here on the equation are all in moles. So 10 grams of N2 is equivalent to, now the molar mass, 1 mole of N2 is equivalent to its 28 grams of N2. You can find that from the periodic table. Now we're going to use stoichiometry to convert 1 moles of N2, well actually it's going to be 2 moles of N2 to 2 moles of N2O5. Because remember, we're trying to go from N2 to N2O5 and figure out how many grams that's going to make. We're then going to multiply this. We're going to divide this by 1 mole of N2O5 to cancel the units of mole N2O5. And we're going to convert that to grams using its molar mass, which is going to be 108 grams N2O5. You can figure that out by adding the molar mass of N2 and O5 together. And what this is going to give you is you're going to do this on your calculator. So it's going to be 10 divided by 28 times 108. So you're going to get around 38.57 grams of N2O5 as your yield. Now we're not done here. This isn't actually the theoretical yield, or at least we don't know that yet, because we need to make sure that if O2 makes even less than this, then O2 is limiting, and the result from that will be the theoretical yield. So you'll see what I mean in a second. So now we're going to check for O2 now. 10 grams of O2. Okay. 10 grams of O2, we're going to convert this to moles. 1 mole of O2 is 32 grams of O2. We're going to use stoichiometry to go from moles to moles of O2 to moles of N2O5. So it's 5 moles of O2 to 2 moles of N2O5. And these numbers, 2 and 5, come from the reaction here. Okay? Then we're going to multiply this by 1 mole of N2O5. Now that we're in moles of N2O5, we can convert that to grams, which is 108 grams per mole of N2O5. And then we just simply finish that calculation. 10 divided by 32 times 2 divided by 5 times 108. That gives us 13.5 grams of N2O5. And this is smaller than this. That means that O2 is the limiting reactant, because O2 is going to run out in the reaction first before we make any more product. And so if O2 runs out first, this is how much product is possible, because the leftover N2, well, it's not going to react with anything. And so the theoretical yield is going to equal 13.5 grams N2O5. This would be the answer. Now, let's say that on the test, you did all these parts correctly. You used dimensional analysis and you found the limiting reactant. Most likely, on test, part B might ask you, find the percent yield if the actual yield is 11 grams. So let's say you did a lab and you actually got 11 grams of N2O5. Now, theoretical yield is theoretically, if you lost nothing, how much product you would make. Now, it is natural for your actual yield to be less, because think about it. Let's say you do a reaction. How do you know that you're capturing all of the atoms? Like if I wanted to blow or combust the air in the room, there's no way I'm going to get every single oxygen molecule, because there's a lot going around so that people in that room can breathe. So the actual yield is just how much we actually make, and the theoretical is how much we could make. All you do is take the actual yield divided by the theoretical yield, so AY over TY, and all you do is multiply that by 100, and you get around 81.5%. So there you have it. So that's your percent yield. So hopefully that brought a little bit of a memory back to you guys on how to do stoichiometry and limiting reactants. This is a very simple example, but I think it'll get you a good enough understanding of where to go from here. If you have any questions, please leave them down below and I will get to answering them as fast as I can. Probably only a couple minutes after, maybe, if you send it. Or if it's a longer question, I'll answer it even later. Thank you so much for watching, and I hope this helped you out on your chemistry journey. See you guys later.